In today's video, I would like to introduce you a very nice problem of Australian Mathematical Olympiad edition 2016, question number 5. Here is the following information. Let a, b, and c be the positive integers such that we have the following equation. We have a cubed plus b cubed equals 2 to the c as a power. Okay? So our goal, we are going to prove a equal to b. In fact, it looks like easier problem to solve, but it's super tricky and challenged. Okay, so the method that I'm going to use by the way of the contradiction all the way down. Okay, before I proceed with the solution, don't forget to support us with your like and subscribe. Also, if you would like to give it a try to this problem, go ahead, pause this video when you want to come back to see the full solution. Okay, let's get into the solution now. By the way of contradiction, suppose a is bigger or equal to 1 and a is strictly inferior than b because we have positive integers. So this one is telling us b equals a plus r. What is a r? Is a some natural numbers. Okay, is r is super equal to 1. By using this assumption, at the end of the term we are going to find the contradiction. Okay, then by symmetry reason also we are going to assume the inverse b is strictly inferior than a. At the end of term we will find the contradiction also. Okay, a and b are symmetry here, so they are playing the same role, so it is enough to show only one side. Okay, so we have the following equation. We have a cubed plus b cubed equals 2 to the c. Okay, by factoring this one out, I will have a plus b is multiplied by e squared minus ab plus b squared equals 2 to the c. Okay, since the right hand side of this equation is a power of 2, that means the left hand side of this equation must be a power of 2 as well. So I will have a plus b equals 2 to the x is taken this form. So the second equation, I will have a squared minus ab plus b squared equals 2 to the y. Okay, now I'm going to make the comparison between x and y. So in order to make the comparison, so I'm going to show a equal to 1 doesn't work here. If a equal to 1, that's mean b equals 1 plus r by replacing a with number 1. Okay, now I'm going to replace this fact into this equation. So we'll have a equals 1, b will be replaced with 1 plus r, which is 2 plus r equals 2 to the x. Now we'll have 2 to the x equals r plus number 2. Okay, now I'm going to work on the original equation. So I have a cubed will be replaced with number 1, b will be replaced with 1 plus r cubed. Okay, I'm going to simplify this one more. I will have 1 plus 1 plus r will be replaced with 2 to the x minus 1 by taking number 1 to the left. Okay, so we'll have 2 to the x minus 1 equals r plus 1. So this r plus 1 will be replaced with 2 to x minus 1 into the original equation. So we'll have number 1 here plus 2 to the x minus 1 cubed equals 2 to the c. Okay, I'm going to factor out this one to see what's given us. So we'll have 2 to the x minus 1 cubed is giving us 2 to the x minus 1 quantity squared factor 2 to the x minus 1. I'm going to simplify this one. I'm going to distribute this one. Is giving us 2 to the x. We'll have 2 to the 2x minus 2 times is multiplied by 2 to the x plus number 1 factor 2 to the x minus 1 equals 2 to the c. Okay, if you check carefully here, this is odd because this one is even, this one is odd. This is odd, this is even because even minus even is giving us even, plus odd. I will have this product, I will have this term is a odd, is multiplied by odd is giving us odd, so that means the whole term is odd. So the left hand side of this equation is a odd, but the right hand side of this equation is a even, which is contradiction. Okay, that means the possibility a equal to 1 doesn't work. Okay, So now I'm going to work on this condition. A is strictly superior than 1 and A strictly inferior than B. Okay. Now I'm going to clean up this board. A is superior or equal to 2 and I will have B is superior or equal to 3 and R is superior or equal to 1. Okay. Now I'm going to make comparison between X and Y, because the reason why I have proven this one doesn't hold. So this one, Y is strictly superior than X if A is strictly superior than 1 and is strictly inferior than B. Okay. Now I'm going to work on this condition. Okay. I'm going to write these two equations in terms of R. I'm going to simplify these equations by taking first equation number 2 as a power on both sides. We'll have A plus B quinary square. I'm going also to distribute this one. Is giving us A square plus 2 times AB plus B square equals to the 2x. Okay. Second equation will be A square minus AB plus B square equals 2 to the y. Now I'm going to subtract equation number 2 from equation number 1. So A square will be cancelled out. 2AB minus AB is giving us 3AB. 3AB. Then B square will be cancelled out. I will be left with 2 to the x minus 2 to the y. Okay. By taking 2 to the y as a common factor, I will have 2 to the y factor 2 to the 2x minus y minus 1, like this. Then now I'm going to replace B with A plus R. So we'll have 3 is multiplied by A, factor A plus R equals 2 to the y is multiplied by 2 to the 2x minus y minus 1. Okay. Now I'm going to take this expression at the top and continue solving our problem. In the last board I was working on this equation and came up with this expression. Now I'm going to break this one into two cases. If A is odd, so since the right hand side of this equation is even, so the left hand side of this equation must be even as well. So in order to make left hand side of this equation even, A plus R must be even. Okay. To have A plus R even, we are going to force R to be odd, because A is already odd. Odd plus odd is giving us even. Okay. And since this one now is even, is multiplied by odd is giving us even. A is odd. Now implies R odd. I'm going to work on this term even number. Okay. You can take two forms. A plus R as an even number will be take this one 2 is multiplied by x, or A plus R it will be written on this form 2 is multiplied by prime P as a odd prime. We don't know yet this term as an even number, it has even factor or has a prime factor. Now we are going to work on it now. First table, I'm going to show perform not divide A plus R. So by the way of contradiction, this is even. By the way of contradiction, suppose 4 divides A plus R. 4 divides A plus R, that's mean, and A plus I equals to B. B is on the previous conditions. According to the divisibility statement, so we'll have B equals A plus R equals 4 times is multiplied by K. Where is the K is a sum natural numbers. Okay. B is a multiple of 4. Now I'm going to take this value and insert it into the original equation to see what it's giving us. A cubed will stay the same. B will be replaced with 4K cubed. I'm going to distribute this one out. I will have A cubed plus 4 to the 3, which is 48, is multiplied by K cubed equals 2 to the C. Okay. So this term is even, but this one is odd. Okay, because we have chosen this one is odd. So now the left hand side of this equation, becomes odd, but the right hand side of this equation is an even, which is contradicts our assumption. Okay, so what which contradict here? That's mean 4 not divide a plus r. That's what we have shown. If you have 4 divides a plus r, that's mean x will be, at least will be tick number 2. 2 is multiplied by 2 is given as 4. That's mean 4 divides this one. This one is not exist. That's mean the large power of a plus r is number 2. Since this 2 is not multiplied by even number, so that's mean it will be multiplied by odd number. So I'm going to work on this one now. By the way of contradiction, suppose p divides a plus r. So we have this expression a plus r equals 2 times is multiplied by prime number. Okay, so that's mean a plus r will take 2p, because we already shown 4 not divide is plus r. We have single unit here. Now p is multiplied by number 2 only here. The large power of 2, it was 2. Okay, in the same time a plus r equals to 2p equals to b. Now I'm going to take this value and insert it into the original equation. So we'll have a cubed plus b cubed will be replaced with 2p cubed. A cubed is given as a cubed. This one is given as 8p cubed equals 2 to the c. As we know, this even, but this is odd. So that's mean the left hand side of this equation is odd, but the right hand side of this equation is even. Is also is contradict our assumption. So this one is telling us p not divides a plus r. That's mean p as a odd prime is not the factor of a plus r. That since 2 is not multiplied by even factor and is not multiplied by odd prime factor, that's mean a plus r it was multiplied by number 1. So the sum of these two terms a plus r equals to 2. Now since a plus r equals to 2, I'm going to force this one equals to this one. So the whole value of this one is taking 2 to the y as a power. If this one is taking this one, that means this one is arithmetically going to take this one. So we already found a plus r equals to 2. Okay, and also since r is a odd, that means a is superior to 3, because we have a is strictly superior than 1. That's why we're taking a superior to 3 as an odd number. And also r, it was superior to 1. So that's mean the sum of these two terms, a plus r, is superior to 4. So this is the contradiction number 1. So I'm going to look for the contradiction number 2 in the same term. So since this one a plus r equals to 2, that's mean equals to this term. So a plus r equals to 2 in the same time equals 2 to the y. We are matching the numbers of this equation. This one is telling us y, that's mean y is taking number 1 here. If y equal to 1, it will be forced to x equals to 0, because y is strictly superior than x, because we already have a plus b equals 2 to the x, which is strictly superior than 1. Okay, if x equal to 0, that's mean a plus b equals to 2 to the 0, which is equals to 1, is strictly superior than 1, which is contradiction. Okay, this is contradiction number 2. Okay, so here it was enough, but I add this one, so I found 2 contradictions in the same case. So now we found the contradiction when we have a as an odd number. Now let's move on to the next case where we have a as an even number. Now if a is an even, a must be superior to 2, and r must be superior to 2 as well. Okay, if a is an even, so that's mean r will be forced to be even as well, because even plus even is given as even, and a, since a is an even is multiplied by even is given as even. So I'm going to push this a inside of this one. It will be written on this form, e squared plus er. Okay, ra or er. If this one was multiplied by even factor, we don't care about this, because the whole thing is going to the power of 2, because the whole thing is gonna go inside of the power of 2. Okay, So the rest, the odd, is going to take, clearly is going to take this one. But if this one was multiplied by the odd prime, a number we will extract from here and go towards 3. I will have a square plus ra. I'm going to make a as a common factor. I will have a factor a plus r. Here is the thing here. As we said, this is even. This is even as well. By the way of contradiction, suppose a equals 2 is multiplied by p as an odd prime, and e plus r equals to q, okay, as an odd prime as well. We don't care if the factor is even, because if the factor is even, you're gonna go inside of this one, we will be okay to go, okay. But if this one was multiplied by the odd factor, it will be a problem. So this one implies p divides a and q divides a plus r, okay. A plus r equal to 2q, okay, and also a plus r equals to b, okay. I'm going to insert this one into the original equation to see what's given us. For the a cubed, it will be replaced with 2p cubed. B cubed will be replaced with 2q cubed equals 2 to the c. I'm going to factor this one out. It's giving us 8p cubed plus 8q cubed equals 2 to the c. I'm going to make the 8 as a common factor, okay. Then this 8 equals 2 to the 3, okay. I'm going to divide both sides by 2 to the 3. It's giving us here 2 to the c minus 3. This one will be cancelled out. Then I'm going to factor this one out as well. So we'll have p plus q is multiplied by p square minus pq plus q square equals 2 to the c minus 3, okay. Since the right hand side of this equation is a power of 2, that means the left hand side of this equation must be a power of 2 as well. So that means p plus q is taking 2 to the I, and p square, it will be written on the form p square minus pq plus q square, it will be written on this form 2 to the j. Since p and q super equal to 3 as a odd prime, that means this term is bigger than this term, because the quadratic form is growing quickly than linear form. So this one is arithmetically is bigger than this one. So that means j is greater than I. This is very important. I'm going to use this one in our assumption, okay. So now the next thing that I'm trying to do now, I'm going to raise number 2 as a power on both sides for the first equation, okay. I will have, by distributing this one out, I will have p square plus 2 times pq plus q square equals 2 to the 2i. For the second equation, I have p square minus pq plus q square is giving us 2 to the j, okay. Now I'm going to make the difference of these two equations by doing this one minus this one. So we'll have a lot of cancellation here. This one will be cancelled out with this one. This one will be cancelled out this one. This one minus this one is giving us 3pq, because it becomes plus here. 3pq equals this one minus this one. We'll have 2 to the 2i minus 2 to the 2j, okay. 3pq equals 2 to the 2i minus 2 to the j. I'm going to take 2 to the j as a common factor. We'll have 2 to the j factor 2 to the 2i minus 1, okay. If we take a look carefully at both sides of this equation, the right hand side of this equation is an even, but the left hand side of this equation is an odd, because p is an odd prime, q is an odd prime, and 3 is an odd as well. So the product of this one is giving us odd, but the right hand side of this equation is an even. To maintain order and make the equation work correctly, we are going to give j 0. If we give j 0, that means 2 to the 0, which is 1. So if we give, which is 1, that means this one is odd. So I will have j, if j equal to 0, implies 3pq equals 2 to the I. I'm going to factor this, the difference of these two squares. We'll have 2 to the I minus 1 factor 2 to the I plus 1. Okay, I have ended with this expression. I'm running out of the room. I'm going to clean up this board and tick this expression at the top and continue with our problem. Since 3 is smaller than pq, I'm going to take 3 equal to this one and pq equal to this one, because this term is smaller than this term. So this is the first possibility. And also q is bigger than p. 3 equals to 2 to the I minus 1 and pq equals 2 to the I plus number 1. Okay, this is the first possibility. I'm going to take number 1 to the left. I will have 3 plus 1, which equals 4, which equals 2 to the 2 equals 2 to the I. This one is telling us I equals to 2. And we found j equal to 0. Okay, but j is strictly superior than I, which is contradiction. Okay, this is contradiction. What does mean contradiction? That means p not divide a, and also a q not divide e plus r. Okay, so the product that we have before a is multiplied by e plus r plus a squared plus er as an even term, not multiple of the prime numbers. Okay, it means the whole number as an even number is taking number 2 as a power. Okay, it's taking this side. A squared plus er is taking 2 to the y. The 3 is arithmetically is going to take this one. Also number 3 equals 2 to the 2x minus y minus 1. Contradiction starts showing up. Okay, have this product a squared plus er equals a factor a plus r. You have chosen a is super equal to 2 as an even number, and r is also an even number. R is super equal to 2. Since the right hand side of this equation is a power of 2, that means the left hand side of this equation is a power of 2 as well. So I'm doing the same job that I did before. Okay, so I will have a equals 2 to the m and a plus r equals 2 to the n. Okay, now I'm going to make this equation minus this equation is giving me r by cancelling out to a from this one. I will have 2 to the n minus 2 to the m. So since n is strictly superior than m, because this term is bigger than this term, I'm going to take 2 to the m as a common factor. I will have 2 to the m factor 2 to the n minus m minus 1. Now we know, now this is even. R is even because we already mentioned a is a even, and is forced r to be even as well. Okay, since this one is a even, I'm going to show this term is taking this term. Okay, by the way of contradiction, we are going to prove p not divide r as a factor of r. Okay, so by the way of contradiction, suppose p divide r, this one equivalent according to the divisibility statement, this one equivalent r equals 2 is multiplied by p. Okay, 2 is multiplied by p as a odd prime. I'm going to take this value and replace it into r. So we'll have a plus r, which is 2p, equals 2 to the n. So I'm going to replace a with 2m. I will have 2 to the m plus 2 to the p equals 2 to the n. I'm going to divide both sides by number 2. Okay, so equivalent, I will have 2 to the m minus 1 plus p equals 2 to the n minus 1. So the right hand side of this equation is an even, but the left hand side of this equation is an odd, because 2 to the n minus 1 is an even plus odd, so that means the whole thing is odd, which is contradiction. What does mean contradiction? That's mean P not divide R. P not divide R, that's mean there is no prime factor inside of this one. So that's mean R is written on this form. 2 is multiplied by x is an even factor. Okay, instead to have a prime factor, we have even factor. R is taking the whole evenness. R as an even term is taking the whole power as a 2 power, okay, into this power 2 to the m. And number 1, because R is multiplied by 1, which is odd, equals to odd as well. 2 to the n minus m minus 1. Now by taking minus 1 to the left, I will get R equals 2 to the m as a first equation. This one is giving us 1 plus 1 is giving us 2 equals 2 to the n minus m. So the exponent of this one equals to 1. Okay, that's mean 1 equals n minus m. In the other word, n equals 1 plus m. I'm going to take this value of n and replace it into the second equation. Okay, I will have a plus r equals 2 to the n. 2 to the n will be replaced with 1 plus m. This one is given as 2 is multiplied by 2 to the m. 2 to the m will be replaced with a, so we'll have 2a. By taking this a to the right hand side of this equation, I will get r equals a. Now I'm going to take this value of r and replace it into this equation. So we'll have a is multiplied by e plus a. This is given as 2a is multiplied by a, which is 2a squared equals 2 to the y. I'm going to keep this expression for a moment. I'm going to find the relationship between y and x by using this equation. So this equation, by taking minus 1 to the left, I will get 4, which is 2 squared is giving us 2 to the 2x minus y. So I will have this exponent 2 equals to this exponent 2 equals 2x minus y, equivalent y equals 2 is multiplied by x minus 1. So this is the relationship between x and y. Now I'm going to take this value of y and insert it into this equation. I will have 2 is multiplied by a squared equals 2. Y will be replaced with 2 to the x minus 1. I'm going to write this one on this form, 2 to the x minus 1 quantity square. I'm going to take the square root on both sides. I will have square root of 2 is multiplied by a equals 2 to the x minus 1. So I have ended with this expression. This is impossible. This is contradiction, because the right hand side of this equation is an integer, but the left hand side of this equation is not an integer. Okay, we found the contradiction on odd side. We have just proven this one. We have proven a strictly inferior than b. So by the way of contradiction, we are going to assume suppose b strictly inferior than a. By symmetry reason, because a b are symmetry in this equation, so that means a and b are playing the same role. So we will do the same job. At the end of the term, we will find the contradiction. So the same thing. Now we have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.